In July of 2010, members of our team went to the Washington State School for the Blind to hold a 3-day workshop for blind middle school and high school students. Our team, led by Dr. Andreas Stefik and Dr. Chris Hundhausen, and consisting of researchers and students from Southern Illinois University Edwardsville and Washington State University, as well as blind programmers and other consultants from across the United States, has been developing software and a programming language with the goal of increasing accessibility of programming software for blind people. At the workshop, we introduced teachers to our software and assisted them in teaching the students about the software, our programming language, and programming in general. Our software, called SodBeans, is a NetBeans module suite that has been in active development for almost 2 years. It is designed to enhance accessibility for the blind in NetBeans by including additional keyboard functionality and providing auditory information about the environment as it is used.
Entering local variables window. Entering output window.
SOD being an acronym for Sonified Omniscient Debugger, the software also provides a debugger that can step forward and backward in a program and that gives auditory information about the progress of a program as it is debugged. The software is compatible with most screen readers, including JAWS, NVDA, and VoiceOver, but it includes its own screen reader behind the scenes. We have also designed and implemented a programming language that is used in SodBeans called HOP that has been designed with the auditory use of the language in mind. We have tested the word choices of the language by surveying both programmers and non-programmers and measuring how much the subjects found that given words related to programming concepts. Our results show that some words commonly used in programming languages do not relate well to the concepts they are meant to describe. For instance, in our tests, we tested words that meant doing something 0 or more times. We found that, for non-programmers, among the words rated lowest for describing this concept were do, for each, while, and for, which are words used for this concept in many popular programming languages. The fact that these words were rated higher among programmers suggests that programmers learn to use them, but their meaning is not immediately intuitive. Words that were rated high by both include repeat, again, and cycle, and we have therefore chosen to use the word repeat in HOP. In HOP, our goal is to eliminate words that are not rated as describing concepts well by non-programmers, even if they are rated high by programmers.
Dean Stengen. I'm the superintendent of the School for the Blind and director of the Services for the Blind, or School for the Blind for the state of Washington. Really taking a look at trying to help folks make some, I think, some huge advancements in accessible programming for blind and visually impaired people, with the idea of first starting out with kind of middle school, high school age kids to stimulate some interest and get probably more people that are blind and visually impaired into the computer programming field.
Before the students arrived at the workshop, we spent a day with the teachers, Sean and Lisa, introducing them to the curriculum and the software. The school will begin using the 18-week curriculum in the spring semester of 2011.
So these are the brown notes.
We also talked to school administrators like Sherry Hahn, the school's digital learning coordinator and IT supervisor, who showed us some of the electronic resources provided for the students.
So this is the first computer programming camp that we've had here.
On day 1, the teachers gave the students an introduction to computer programming.
Learning basic concepts, and then you'll be able to write your own computer program. Tell me if this would qualify as a computer program. Add flour until paste is sticky. Knead until firm. Roll thin and cut. Bake in a medium oven until light brown. Place on rack until cool. So what do you think? Anybody? Do you think a computer can understand what those directions are?
No. There's not enough detail. I think you said roll until firm.
Mm-hmm.
If I was going to write this in a code or in a recipe, roll for about 20 minutes.
Okay.
You need to be more specific.
Yeah, you need some real measurable criteria that the computer understands.
The teachers used manipulatives designed for the students, some of whom were blind and some of whom had limited vision, to teach programming concepts.
This is going to represent your integers that you're going to be putting in the computer.
Here, a blind student is using the integer manipulative. Some of the students were totally blind or primarily used Braille, and others had low visual acuity and used large print media, and the manipulatives were designed to meet the needs of both. For example, on this die, not only are there large dots on a surface of contrasting color, but sequins were used to produce a raised surface that can be felt by blind students.
It is actually a light switch that you would put in someone's house.
Light switches labeled on one end with the large print T, as well as T in Braille, were used to teach the concept of a Boolean.
T stands for true, and if you switch it the other direction, it stands for false. Right. This is called a data type called Boolean. Does everyone say that? Boolean? Boolean. These are values that can only be true or false.
After introducing the concepts, the teachers introduced the students to sod beans and hop, and the students started writing basic programs.
Everybody's got sod beans up there?
Will be the line after action main. So you can go all the way to the top to action main and hit down arrow.
You can write your name, or you can write, hello, my name is. And since you're telling the computer to say, and it's text, it should say what you write.
In addition to other audio features, Sodbeans works with Hop to produce audio output for programs in addition to written output using a say statement, which the students began working with here. Instead of printing to a console, a programmer can have the computer give auditory output. Day 2 started with an exercise reinforcing the concepts of variables and mathematical operations.
Popcorn, which is 5, minus butter, which is 4, is 1.
Whales minus water.
So how many whales and how many water did you have for
6 whales?
6 whales?
1 water.
3 cakes, 2 people, 1 cake is left.
What would be the language for the remainder?
Mod.
Say it?
3 mod 2. Or
Yeah, is 1.
Yeah.
Equals 1. Good.
After the exercise, the students were taught to write code that performs mathematical operations.
So sum is going to be our new variable. What is sum going to equal? Justin?
After instruction, the students were given time to write their own code using what had been taught so far.
You can do your own. Yeah, you can change it, change the operation, change the name of your variables. Play around with it. See if you can get it to
Do something different.
do something different. Yeah.
After working on their programs for a while, some of the students shared theirs with the rest of the students using the debugger.
Calling action input number colon text. 4. I-4. The number you entered was 4. Zippy. Enter another number. 0. Start of document. 10 to 0. The number you entered was 0. Sum to 4. The sum of the two numbers was 4. Difference to 4. The difference between the two numbers was 4. Product to 0. The product of the two numbers was 0. Returning from option main.
Overall, we found that the students were satisfied with Sodbeans.
Things make sense when it's talking to you.
The teachers found the software to be useful, but even more thought that the programming experience was educationally beneficial.
Being able to be creative allows kids to problem solve. It doesn't, don't think making up a game, but it does. It allows you to problem solve, which carries on everything you do in life. So for them to have to create something on their own and it give them feedback that it works is helping with that process.
At the workshop, we not only brought computer programming to blind students, most of whom had no prior experience with programming, but we learned about how we can retrofit our product to better serve the needs of the blind community. We hope that, through our work, blind students will learn to program and will be encouraged to pursue professional study of computer science and to enter other technological fields.